Alright, this is problem or 2007 Form B problem number 1. Um, and you are allowed to use your calculator on this. So what we're gonna do, A is asking us to find the area of R, and we know that the formula for the graph is e to the 2x minus x squared. So the hardest part about these is finding the intersecting points. So we know the integral is going to be the integral of e to the 2x minus x squared minus 2, because we're imagining that it's this same graph but moved down 2 points y. So that imagining this y equals 2 is actually y equals 0 dx. But what we're looking for is this number, which is going to be the x value right here, and then this number, which is going to be the x value right here. And how we're going to find that is when e to the 2x minus x squared is equal to 2. And the easiest way to find that is going to be when 0 is equal to x squared minus 2x plus ln of 2. So we want to do this problem as quickly as possible, and so you're going to plug this into your calculator, into your quadratic formula program, and find the 2x values, and I'll do that real quick. Alright, so the two answers are 0.446 and 1.554, but I'm not going to round those. I'm actually going to store them as a is equal to 0.446, but not rounded to 3 decimals, the entire thing, and then, which I believe is 0.4460 or something, and then b is equal to 1.554 ... And that, then we can plug in this integral just into our calculators, and I'm going to have to do that again, but I'll be back in a second. Alright, so my calculator gave me told me that the answer is 0.514, and so I'm just going to plug that in. There's no more work that's necessary because it's a calculator question. You can just write this. They're probably looking for the answer, the integral. Yeah, probably 2 points for the integral and 1 point for the answer. So that's A. And then B, find the area S. S is this section here. So again, we're looking for this point, which looks like 0, and this point, which looks like 2. To make sure, real quick, we're going to say 1 is equal to e to the 2x minus x squared, which really means, because we know 1 is really e to the 0, which means to solve this, we're going to say 0 equals 2x minus x squared. And you could do this in your calculator. It's really much faster to do it in your head, though. X is equal to 0 or 2. So, the integral we're looking for is the integral from 0 to 2 of e to the 2x minus x squared minus 1 dx, all minus 0.514. And I'll solve that out really quick again, but because we're looking for this integral here is really, it's not just s, it's actually everything underneath here, and so we have to subtract the r to find s. Alright, so the answer you get is 1.546, and that's the area S. And then part C, write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated around the horizontal line y equals 1. Alright, so we're looking for volume. You know that volume, I have to think about this for a second. Okay, so since the volume is pi r squared, or at least that's or at least that's the equation we're going to be using here. The way that we need to solve this is looking for the volume of R plus S and then subtract the volume of just S. So the way that we'll do that is we need the radius. Alright, so it looks like what we want to do is I'm actually going to copy and paste a new copy of the graph, but pretty much we're going to do pi, the integral from a to b of e to the 2x minus x squared minus 1 squared dx minus the integral from a to b of 1 squared dx pi. And I'll explain all this to you in a second when I copy in the graph, but it all makes sense when you think. Okay, so we're imagining that this part right here, R and S together, gets rotated around y equals 1. And so to find the volume of that donut that R makes, we need to find first, what we're doing is we're taking the integral from a to b, which means the only part that we're looking at is right here between this point and their parts down. So when we say from a to b of this, of e to the 2x minus x squared minus 1 squared, that is giving us this whole shaded region here. That's what we're getting, and we're getting the volume of that rotated. And then, this is a pi, by the way, and then we're subtracting pi of the integral from a to b of 1, and this 1 squared comes from 2 minus 1. Maybe I'll write that in actually because it's not very explanatory, but 2 minus 1 squared dx. And so this is confusing that we're using a and b again, but it's because we're not subtracting all of s, we're just subtracting this little square here. So to simplify this out, it would be pi a to the b of e to the 2x minus x squared minus 1 squared dx minus the integral of, actually I'll not even do that, I'll do minus 1 dx. So yeah, that's the simplest way to put it. Yeah, it all just comes from this pi r squared, pretty much.